Hello students, welcome to Learner's Planet, Theory Session 10 of Carbon and its Compounds. In our previous session we were discussing about the properties of alcohol and we did in details the properties of ethanol. In this session we will discuss the physical and chemical properties of acetic acid, which is a common name of ethanoic acid. So let's start our discussion. Here it is, we study about carboxylic acids. What are carboxylic acids? These are the carbon compounds containing carboxylic acid group, COOH group, and these are called as carboxylic acids. How these are formed? So I am taking example of an alkane, that is C2H6. Now what happens when a hydrogen or when its hydrogen is replaced by COOH group? Then what is formed is an acid. That is, what will be the acid of this? It would be C2H5COOH. Okay. So what is C2H5? I can write it as R and COOH. This is what? Acid. So that is carboxylic. When there is a carboxylic group, then it is called as what? Then it is called as an carboxylic acid. These are commonly known as organic acids. Why organic acids? Because these are found in living organisms. So they are called as organic acids. The simplest carboxylic acid is methanoic acid, that is HCOOH, and its common name is formic acid. Ethanoic acid is the second member of homologous series of carboxylic acids. If I want to write the homologous series of carboxylic acid, what it would be? Homologous series of what? Of acids. So it would be methanoic acid, HCOOH, ethanoic acid, that is what? CH3COOH. It means how many carbon atoms would be there? It would be 2. So there is ethanoic acid, CH3COOH. Propanoic acid, C2H5COOH. Butanoic acid, that is C3H7COOH. So this will be the homologous series of carboxylic acids. So coming to acetic acid. So what is the formula of acetic acid? CH3COOH. And what is its IUPAC name? It is ethanoic acid. And what would be its structural formula? Structural formula. What will be this? Eth, meaning what? How many carbon atoms? 2 carbon atoms. Okay. And so what it will be? CH3, and there would be COOH. So this is H, H and H. So this is the structural formula of ethanoic acid or acetic acid. The acetic word is derived from the Greek word acetum. Like formic word is derived from the Greek word formica, meaning ant. Okay, so in diluted form it is used as vinegar. Now let's take up the physical properties of acetic acid. Acetic acid or ethanoic acid is a colorless, corrosive liquid with a pungent smell at ordinary temperatures. Corrosive means it is an acid. So what it is going to do? It is going to release H ions and that will corrode the metal. Below 290 Kelvin, it solidifies to an icy mass called as glacial acetic acid. So students, you should not get confused about the glacial acetic acid and acetic acid. It is the glacial acetic acid that is at 290 Kelvin, it will get solidified below 290 Kelvin, and it is forming what? Glacial acetic acid. The boiling point of ethanoic acid is 391 Kelvin. The boiling point of water is how many kelvins? It is 373 Kelvin. Okay, that is 100 degrees centigrade. So it comes out to be 373 Kelvin. And your boiling point of ethanol is, ethanoic acid is 391 Kelvin. It is miscible with water, alcohol and ether in all proportions. So it can get easily dissolved in water, alcohol as well as in ethers. Ether because it is an organic compound, and water and alcohol because it can form what? Hydrogen bondings there, or there can be the force of attraction between, say I am writing a general acid, that is C double bond O and OH. So there can be a force of, there is a force of attraction between oxygen of acid and hydrogen of water. Okay, so that is why this is soluble. Fine. So this is also soluble in alcohols. In alcohols, what all is there? There is, if I am taking RC, OH and double bond O, what will be happening? There is a force of attraction between H, O and. So because of this weak, and remember these are weak forces of attraction. So that is why they are miscible. It is a good solvent for phosphorus, sulfur, iodine and inorganic compounds also. Now let's move to the chemical properties of acetic acid. Now action on litmus. If we are calling it an acid, what action it will have on the litmus paper or litmus solution? Acetic acid is acidic in nature, and so it turns what? Blue litmus solution red. Say, let's take up this acetic acid. What is the formula here? It is CH3COOH, and this acetic acid dissociates in aqueous solution, or this dissociates and it forms what? It is forming what all ions in the solution? It is forming CH3COO minus ions plus of H plus ions. So what are these ions called? These are called as acetate ions. And what type of ion it is giving in the solution? It is giving H plus ion. So it is an acid. Those substances which give H plus ions in solution are what? Acids. So what effect it will have on the litmus solution? It will turn blue litmus red. Now your acetic acid is a weak acid as it undergoes partial ionization in solution. So this is undergoing what? Partial ionization. This is not complete. Had it been like this, that is CH3COOH, and had it been ionized like this, CH3COO minus plus of H plus, it would have been a strong acid. But is it ionizing like this? No. So it is a weak acid. It undergoes partial ionization. So that is why organic acids are weak acids. Now there is another property, that is reaction with the chemical properties of acids. That is the reaction with sodium hydroxide. How it is reacting with sodium hydroxide? It reacts with sodium hydroxide forming salt and water. So it is reacting with sodium hydroxide forming salt and water. So what are the products which are formed here? It is salt and water, that is ethanoic acid plus sodium hydroxide is giving what? Sodium ethanoate and water. I'll write it clearly. I think it's not visible. It is sodium ethanoate. Okay. How the sodium ethanoate is formed? Again your CH3COOH plus of NaOH, and it is forming what? It is forming sodium ethanoate. How? This H of acid, this is replaced by sodium, and it is forming CH3COONA, and remaining is what? Water. That is this H and this hydroxyl will combine and it will form what? Water. So this is the reaction with sodium hydroxide. Alcohols don't react with sodium hydroxide, remember. Alcohols react with metal, that is sodium, but they do not react with sodium hydroxide or carbonates or bicarbonates. Reaction with carbonates and bicarbonates. Your ethanoic acid or acetic acid reacts with carbonates and bicarbonates forming sodium ethanoate, water, and what is evolved is, it evolves carbon dioxide giving an effervescence. So it reacts with carbonates and bicarbonates forming sodium ethanoate, water, and evolves carbon dioxide, or carbon dioxide is evolved giving effervescence. Now it's CH3COOH plus of sodium carbonate is giving you what? Sodium acetate. Plus water plus carbon dioxide, and due to this carbon dioxide there is brisk effervescence is observed. Likewise, your ethanoic acid or acetic acid is reacting with sodium bicarbonate and is forming what? Again the sodium acetate, water, and brisk effervescence. So the distinction between alcohol and acid is that your alcohols do not react with bases like sodium hydroxide, like sodium carbonate or sodium bicarbonate. But acids do react with sodium hydroxide as well as with carbonates and bicarbonates. Reaction with bicarbonates is used as test for the presence of carboxylic group in a compound. That is, when it is reacting with a bicarbonate, when you are provided with an organic compound which reacts with a sodium bicarbonate and gives out a brisk effervescence of carbon dioxide, then what is the conclusion? The conclusion is that the given organic compound is a carboxylic acid. Let's take up the next property here. This is the reaction with metals. Just like alcohols, they are reacting with metal. Acetic acid reacts with electropositive metals like sodium and zinc to give the respective acetate and liberate hydrogen gas. Again, what is happening here? That the hydrogen is replaced by sodium. That is this hydrogen is replaced by sodium, and this hydrogen is evolved out as hydrogen gas, H2. And what is the sodium forming? It is forming CH3COONA. That is, what is the name of this compound? Sodium acetate. Okay. Now there is one more reaction, that is reaction of acids with alcohols, and this reaction, students, is also known as esterification reaction. Now what is it? Ethanoic acid reacts with alcohols in the presence of small amount of concentrated sulfuric acid to form esters. That is, your ethanoic acid with alcohol is giving ethyl acetate and water. I'll elaborate this. See, if I'm taking some other acid like C2H5COOH, that is what? That is propanoic acid. How I have named it? How many carbons are there in this compound? What, 2 and 1? 3. So what would be the root word here? Prop. There are single bonds between carbon atoms. So what would be the primary suffix? N. And for COOH, what is the secondary suffix used? It is oic acid. So its name is propanoic acid. That is reacting with what? It is reacting with an alcohol. Let's take up a simple alcohol, that is HOCH3. I'll tell you why I have written it in a reverse order. Why I have not written it in CH3OH form. Because if we write compounds like this, it is easy for us to predict the products. Now here what happens, that this H plus and OH minus, they combine and they form water. Now what are the things left? The things left are, this is C2H5COO. I think it should go like H of alcohol and OH of acid. It goes like this. So I'll write it correctly here. It is CH3COOH plus of CH3OH. I wrote it in a reverse order, so it will give me what? HOCH3. Okay. Now there is a formation of water molecule like this, and it will form C2H5CO and OCH3 plus of H2O. Okay, so what is our product here? Plus C plus H2O. Sorry students. So this is propanoic acid, and what I have got here? I have got an ester here. What will be its name? Its name would be methyl propanoate, or I can write it as, ethyl acetate. Okay, so this is one of the ester which I have obtained, and this reaction, students, is called as what? Esterification reaction. Now what are these esters? Esters are volatile, sweet smelling liquids. Esters are used in making perfumes and as well as flavoring agents. You must have seen those vanilla essence or mango essence or strawberry or raspberry, which gives flavors to your ice creams and bakery products. These are all used, they all contain esters. So let's see this hydrolysis of esters. When an ester is heated with sodium hydroxide, it dissociates to form the parent alcohol and sodium salt of carboxylic acid. That is, this is an ethyl ethanoate. When it is heated with NaOH, so it breaks down into the parent alcohol and the acid, that is CH3CH2OH and CH3COOH, that is the acid. Okay. The alkaline hydrolysis of esters is known as saponification. So this is also called as what? Saponification. And here this acid is not formed, students. It is, what is formed here is the sodium salt of acid, that is CH3COONA, that is sodium acetate. Okay. Now I'll tell you how we just find out this. I'll just remove this reaction and I'll write a new reaction, so that this is going to help you out in finding out which ester and which acid is being used. So let's take our acid, that is C2H5COOCH3, and it is heated with what? It is heated with NaOH. Okay, so this is heat, and it is forming what? It is forming an acetate and an alcohol. So it is C2H5COONA plus of CH3OH. Right? That is your left side part of acid, of ester, is made of acid. Okay? So the left part is made of your acid. So this will form an acid and this will be the alcohol. Right, children? So this is how we find out the products. Okay, I'll give you a few examples of this also. The molecular formula of ester is C4H9COOC2H5. So what is the molecular formula? C4H9COOC2H5. What you have to find out? What is the formula of alcohol and acid which will be formed on its alkaline hydrolysis? So what I told you was that the left side part of the formula of an ester is derived from acid, and the right side part of the formula of ester is derived from alcohol. So I can just mark it like this is the left side part, or this is derived from acid, and this part is derived from alcohol. So on heating with sodium hydroxide, what will be my products? What is an acid here? That is C4H9COO Na, that is my acid, or C4H9COOH is my parent acid. And what is my alcohol? It is C2H5OH. So this is the way, students, how we find out that an acid, an ester, is formed of what all? Acids and alcohols. I hope you understood this. You just try with few more molecular formulas of esters. That the only thing you have to remember is that the left side part is formed of acid, and the right side part is formed of an alcohol. Now let's take the next question here. What is given? What are the names of the given compounds? So I just wanted to give you an example how you have to decide the names, right? Now here, what is the thing? It is C3H6O. So it would be the formula of what type of compound? It would be, there are 3 carbons, right? So can we write it like this? C2H5OH. Can we write it like this? No, we can't write, because there are 3 carbon atoms. Okay. What else can be the thing? So this one is wrong. How many carbons are there now? 3 carbons. How many hydrogens are there now? 6 hydrogens. How many oxygen? 1. So in your exams you will be provided with the formulas like this, and you have to work out that which compound it is. Right? Now this one, what is it? What will you write about this? What compound is this? I think I can write it like CH3. What compound is it? So it would be what? Can I write it like this? CH3CHO. Can it be written like this? C2H4O. So both are aldehydes. This is C2H5CHO. Okay, so both are what? Both are aldehydes. Or I can also write this like CH3, C double bond O and CH3. This is what? This is a ketone. This is an aldehyde. Okay, so this is the way how we write the formulas. Yeah, there are few more compounds given, that is C2H4O2. What would be this? There are two oxygens. In which organic compound there are two oxygens? In acids there are two oxygens, right? So just try with acids, that is CH3COOH. This is what? This is an acid. This is again, it can be either a ketone or an aldehyde. What aldehyde it is? It is C2H5CHO. So it can be a ketone or an aldehyde. Right? So such type of questions, I just wanted to give you the example. Such type of questions can also be given. Now let's take up the tests for carboxylic acids. A carboxylic acid can be tested by any one of the following tests, like with sodium bicarbonate. What happens? Carboxylic acid reacts with sodium bicarbonate, forming its sodium salt water, and it gives out what? A brisk effervescence of carbon dioxide. So evolution of carbon dioxide with brisk effervescence shows that the given organic compound is a carboxylic acid. Why bicarbonate is used? Because alcohols do not react with bicarbonates, or even phenols, they do not react with bicarbonate. It is only carboxylic acid which reacts with bicarbonates. So we are using what? Bicarbonate. Let's see another test for it. The organic compound, the given organic compound which is given in your test tube, is warmed with some ethanol and 2 to 3 drops of concentrated sulfuric acid. What is this reaction called? It is called as esterification reaction. A sweet smell. Why the sweet smell is coming? Due to the formation of ester. And it shows what? That the given compound is a carboxylic acid, because only this acid forms esters with alcohol. So out of these two tests, and one is of course the litmus test. It turns blue litmus red. So these tests confirm us whether the compound is an acid or any other organic compound. Now let's take up the uses of ethanoic acid. Ethanoic acid is used in the manufacture of dyes, perfumes and rayons. It is used to coagulate rubber from latex. Latex, that is the latex of the rubber plant. It is used for making cellulose acetate, which is an important fiber also. It is also used in the form of salts in medicine and paints. Let's see a few more uses of it. It is used in the form of acetates of aluminium and chromium, and is used as mordants or dyes, which makes the dyes perfect. That is, mordants are used to stick the dye to the substance. In dilute form it is used as vinegar, and in the concentrated form it is used as a solvent. In the form of organic esters it is used as perfumes. So students, this organic acid or the carboxylic acid is a very important organic compound. Now I'll conclude this lecture. And in this session we discussed about the properties of acetic acid. I hope you understood this. In my next session I'll be telling you about the soaps and the detergents. Okay? Thank you students. Thank you very much for listening patiently.